All right, so let's discuss about netting. What is netting and how we will configure the net into the checkpoint. So we will discuss about that. So maybe you are already, some of you are already aware about netting and some of maybe not. Okay. So let me just discuss these things. Basically, netting is just going to provide, facility to translate one IP into other IP. So this is the netting introduction. So using netting, when you apply net, so you translate one IP to another IP. Okay. So this is going to save your public IP because usually uh, it translates private IP into the public IP. Okay. So a private IP, if you have a network or single host, you want to translate into the public, so you can do that. Okay. You can configure the netting for that. So what's the benefit you get when you are translating this? One thing, you would be able to hide your private IP, I mean your LAN IP, okay, when you are interacting over the public network. So it would be always interacting via your public IP, not a private IP. So it is going to provide you security by hiding your private IP. The other benefit of the netting is private address by default is not routable on the internet. Okay, so if uh, your PC having the private address and it want to access internet, so definitely it required a public IP. So when you net that, so your packet from, when you generate the packet from your PC, which is from, private IP range, so this is going to be route over the internet via netting process. Okay, when we talk about, private IP, so private IP is basically free. Okay, so there are some certain range assigned into IPv4 and IPv6 for the private IP. Okay, so by default, private IP is free. Okay, you can get these private IP uh, from the network administrator. Okay, so basically, network team is responsible to manage the private IP in any organization. Okay, so this is free. Private IP are free. When we talk about public IP, so public IP is unique over the internet. Okay, this is not free. If you want to use a public IP, so definitely you need to purchase it. Okay, and how you would purchase? Basically, you would purchase from the ISP, and ISP is further is going to purchase for IANA organization. Okay, and from there ISP is purchasing the public IP addresses. So if you talk about checkpoint netting, how checkpoint supports net. So in checkpoint we have three types of netting. If you want to configure netting in checkpoint, so you can configure in a three-way. One is the hide net, other is auto net, and the last one is the manual net. So hide net, if you know about netting, so basically hide net is kind of PAT. Okay, so when you configure the hide net, this is a PAT, port address translation. That means one IP or multiple IP can be netted by a single public IP address. So this is equivalent to PAT. This AutoNet, this is equivalent to dynamic net. And then finally we have manual net. Okay, for manual net we can say using manual net we can go and we can configure static netting. When we want to have static netting, so we can use a manual net. So basically one to one translation. If we want to have one to one translation, we can go via static net or we can go via manual net for one to one translation. Okay. So in checkpoint supports object-based netting. So basically, if you want to net anything in checkpoint, so basically you would create a object for each thing. For example, for network, you would be creating your object. So for example, if you have a subnet 192.168.1.0, this entire subnet, This is /24. So obviously this subnet is network type. So what you would do if you want to create hide net or auto net, okay, so definitely you can define the netting rule. You can enable the netting rule within the object. And once you enable the netting rule within the object, automatically some of the rule is also going to be added into the net policy. Okay, so that's why if you go via hide net or auto net, and if you enable the net rule net setting on the object, obviously it is going to add the automatic net rule. Okay, so these are the net type we have. Okay, but when we talk about, sometimes you might have heard, inbound net, outbound net, or source net, destination net. You might have heard these terms as well. Okay, you have heard that you have configured outbound net. You might have heard this term, outbound net. So when you say outbound net, this is source net. This is source net. Might be you have heard about this term, source net. And when you say inbound net, sorry, what did you say? Do not?
Destination net.
Yes, right. So inbound net is kind of destination net, right? So what is the difference between source net and destination net, and how you can achieve if you want to configure, your outbound net or inbound net, source net or destination net, we can say. So how you can configure on which kind of net you would configure for source net and what kind of rule you would configure for destination net. So obviously using this hide net, you can purely configure source net.
Sorry.
Using this hide net, you can configure source net. But in AutoNet, if you want to define AutoNet, and in AutoNet, if you go via static one, okay, here you would configure a static rule, okay. So you can achieve both things. You can achieve source net plus you can achieve the destination net. That means this is going to add the bidirectional net rule, okay, from in to out and out to in when you configure a static net. Okay, using auto, you can go and you can define static as well. So using this, you can achieve both one. Using AutoNet, when you select in AutoNet static mode, so you can achieve both. You can achieve outbound plus you can achieve inbound. Both you can do. And similarly, using manual net, what you can do, manual net is going to provide you freedom that you can customize net rule as per your net policy, as per your requirement. So manual net basically we use most of the time, manual net we use for the destination netting. So this manual net, this is pure static netting over here, and you can use this manual net for, destination netting, destination netting. Okay. So we will see one by one these kind of netting, and we will understand what is outbound net and what is the inbound net, means what is source net and what is the destination net. Okay, so let's understand one by one all these things. What is source net and what is the destination net? Because if you understand the source net and destination net properly, so you would be able to, troubleshoot it much better way. So let me just open a paint over here. Let me draw a diagram for telling you source net and destination net. MS Paint. So right now we are going to understand source net. What happened in source net? SNet. Source net is also known as SNet, which is source net. All right. So how you you can understand what is source net. So basically, let's consider you have the source, okay, which is your PC in the network. This source is connected to, let's say, firewall. Let me draw firewall over here. Let's say this is a firewall. Okay, so this is firewall, and firewall is further connected to internet. Okay, let me just write here. This is internet. You have some interfaces on the firewall. So let's say this is Ethernet 1 and this is Ethernet 0. And this is the PC which got the IP like 192.168.1.10. This is the /24. And by default, the gateway for this PC would be, default gateway would be the firewall IP. Obviously, it would be 192.168.1.1. This is the default gateway for this PC. And firewall Ethernet got some IP, let's say 192.168.1.1. Similarly, outgoing interface got some IP, that is 100.0.0.1. Okay, so when you want to configure source netting, okay, so let's say you have some server on the internet. Okay, let's say the server we have, this server we have on the internet. And this server is NetMinion.net. And this server got some IP, let's say 40.0.2.1. This is the IP of, let's say, NetMinion.net. Now, the situation here, your client, this client PC, want to access internet. Okay, so when I say internet, it want to access NetMinion.net. Okay, so what kind of netting you would configure on the firewall so that firewall would able to translate this and would allow this client PC to access NetMinion.net. So what kind of netting you would configure here? So what you can do, basically, you need to configure here source netting. So when I say source net, here you need to configure source net, because your source IP need to be changed into the public IP. So you need to configure here source net. Okay, I already mentioned on the top. So I would say I would net my private IP into the public IP 192.168.1.10. This IP would netted further to one of the public IP, and that public IP is outgoing interface of the firewall. So when I say outgoing interface of the firewall, so basically we are saying here, hide behind the gateway. Hide behind the gateway. So this kind of netting would be equivalent to hide net On checkpoint language, this would known as a hide net. Okay. And in normal language, this would known as a source net. So here, this PC would be netted on the public IP of the outgoing interface. That means 100.0.0.1. This would be netted on the 100 this IP 100.0.0.1. Okay. So let's say what happened before NAT and what happened after NAT. Let's see here. So let me just draw a line over here, which is going to segregate before NAT and after NAT. So let's see what happened before NAT and what happened after NAT. So this side I would write before NAT. And this side I would write after NAT. So when you generate some traffic from your PC, so basically on the traffic there should be some information. So let's say when you generate the traffic, so on the traffic there is some information. What is the information on the traffic? Source IP, source port number, destination IP, and destination port number. Okay, so there would be some source IP, then source port number, then destination IP, and destination port. This is not a SIP, this is source IP. So on the packet, there would be some field, source IP field, source port number field, and destination IP field, destination port number field. Okay, so let's understand when this client PC is going to generate the packet. So what would happen before NAT on the request? So basically this is going to request, generate some request to access the web page. This is request to server. And then server would also going to reply. So this is, let's say this is reply. This is reply. Okay, so now what happened when this client is going to generate the traffic? So what would be the source IP by default? The client IP, right? The source IP, because traffic is originated from this client PC. So source IP would be client machine IP 192.168.1.10. Source port number. Can you imagine what would be the source port number?
Source port number anything from 1 to 65,500.
Yeah, but you know it would be always more than
1023. 1024.
Above to 1023. So maybe 1024, 1025. Any port number should be maybe 7,000, 5,000, 3,000, something like that. Any kind of port number it would be. So I would consider that. Let's say source port number is 1024. Destination IP. So let's say destination IP is, it is trying to access NetMinion.net, right? So destination IP would be 40.02.1. NetMinion IP 40.0.2.1. That would be destination port number. Destination IP. And what would be the destination port? Because my client PC may be accessing NetMinion.net on HTTP port or maybe HTTPS port. So maybe port number would be 443. Okay. Now this is before NAT. When after that, the firewall is going to do the NAT, and it is going to change the source IP onto new IP. So what would be the new IP over here? So it is going to change the source IP. It would new IP would be
Firewall outside.
firewall outside interface IP, right? 0.0.1 because NATed IP. And what would the say source port number? Source port number would remain same. Source port number is not going to change. 1024. It would be destination IP. Rest of things would be same. Okay. Destination IP would not change over here. 0.2.1, and destination port would remain same. That is your port number 443 HTTPS service. After when this reaches to the server, if the server is responding, accepted the traffic, okay, and server must be replying that. So on the reply, okay, when this is the client request, and this is the server reply. So in server reply, what would happen? Your source IP, because this time server is replying, so
Server.
server would be replying. So here would be source IP would be server IP 2.1. Source port number, that is server port number 443,
443.
and destination IP. Would server reply to your private IP? No, this would reply because server is receiving the traffic from where? 100.0.0.1. So this would be 100.0.0.1. And the destination port, it would be 1024. 1024. Now, this is the server reply. This server reply would also cross the firewall after some time. When it crossed to the firewall towards the client PC, because the firewall job is send the traffic towards the server securely, and when this is replying, so firewall should reply that, and it would reply to that client PC. So in that case, your source IP would be remain same because the reply is coming from where? 40.0.0.40.0.2.1. So your reply would be coming from here 40.0.2.1. Your source port number would remain same, that is 40443. This is reply, and your destination port IP would get changed over here. Instead of this, okay, the firewall is sending the traffic to this PC. That means 192.168.1.10. And finally, this is the destination port number. What is the destination port number? It would be 1024. So this is server reply. Server reply. So we can say that this is a number one packet. Okay. Then it went to the firewall. Firewall changed the IP. Did the NAT over here. After netting, it is changing the source IP. So as you can see that source IP is being changed over here. This IP is being changed, and that's why here we can say here firewall is performing source net. Okay, so source net is nothing, but you can understand in this way that when the source IP get translated or when get netted, so that kind of netting is known as a source netting. And we need to make sure that in the request, when in the request source IP is going to be changed. Okay, so that kind of netting is known as a source netting. As you can see here, this is the source IP, which was before the netting. When NAT happened, okay, because on the NAT we have defined the rule that hide behind gateway, so it is going to NAT to the gateway IP. So here you can see that source is being changed. Is that clear? Source NAT.
Yes.
Everyone?
Yes, it is clear.
Okay, great. Okay, so this is source NAT. What happened in destination NAT cases? Okay, let's see. And after that, we will go for the configuration. So we understood the source net. Now let's talk about destination net. And in destination net, we are going to add one more scenario over here. Sorry. Now we will learn about destination net. Okay. In destination net, we can consider that we have one more server or one more zone we have, and that is DMZ zone. So basically you would configure destination net most of the time. You would configure destination net for your DMZ zone. Okay. So let's consider that you have DMZ server, which is hosting the web services over here, maybe web services. And the web service is like labs.netminion.com .net. Okay, this is the web service, and let's say this web service is where this web service is stored into the DMZ zone. So basically we place the server into DMZ zone, which is publicly available. Okay, means we have web server, file server. So those servers we put into the DMZ zone. So this is entire DMZ zone. So Ethernet 1, let's say this is a part of DMZ zone which is having IP 172.16.1.1, and this DMZ server which we have, it has the private IP by default, that is 172.16.1.10, and this is running, the web service which is running labs.netminion.net. Okay, so in that case, what would be happening over here? Your firewall is doing some kind of netting, okay, and that netting would be known as a destination net. So we will talk about them. Before net, this would become here, this would become here. Okay, let's remove this. Okay, so now what we will do, let's say I just want to publish this server labs.netminion over the internet. So we must have, IP range over here, IP subnet available here to do the netting. So basically when my organization is going to take the, internet connection from ISP, let's say this ISP is AT&T, let's say this is AT&T, one of the ISP. Okay, and when my company purchased the, this connection from AT&T, so my company also purchased the public IP pool. Okay, so let's say my company purchased this public IP pool 100.0.0.0/24. This IP pool purchased by the company. There, and out of these IP pool, there are two IP has been used. One is on the Ethernet interface, and other is on the ISP side. Whatever the ISP side, we have modem. So modem or router. Over there, the another IP is used. Let's say you have used 100.0.0.254 on the ISP side. Now, how many free IP we have? This is /24 range. So it is having 254 IP. Out of 254, 2 you have used. So now you have 252 IP are free. Okay. So now what you would do, you would NAT this labs.netminion.net, which is having the private IP. You would NAT this into the public IP. So let's say you did netting over here. Maybe you went for the static net or manual net, whatever you did. Basically, let's say you have did manual netting in checkpoint term. You have configured a manual net. In manual net, you have said that your 172.16.1.10, this server get netted to the public IP. And what is the public IP? So you would take from this pool. So let's say you have taken that 100.0.0.50. This would be the public IP. So what would happen from internet if someone is trying to access labs.netminion.net? So what it would be getting, it is getting this public IP, and now it would try to request to this public IP, and this public IP virtually active on this outside interface of the firewall, right? So how would be request? How would be request and how would be reply basically? So let's understand how would we request. So basically, when this client is going to generate access for labs.netminion.net. So on the source IP, it would be the client IP. So let's say this client IP having public IP. Okay, each client would having the public IP. So let's say for this client, the public IP is kind of 135.1.1.120. Let's say this is IP of the client, okay, who want to access my labs.netminion.net. I mean this public IP. So it would generate on the source IP. Whose IP would be? On the source IP, it would be 135.1.1.120. This would be on the source. What would be the source port number? So any random port. So let's say 5621. This is the source port number. Any random number it would take. And destination IP. So destination IP would not be server IP. It would be netted IP. So it would be 100.0.0.50, because it would be able to access public IP, not a private IP. What would be the destination port number? So labs.netminion.net, it is running on port number, let's say 443. So this would be the destination port number. After that, the traffic would go where? The traffic would go to the firewall. Firewall would do NAT over here. Okay. So firewall is going to perform a netting at this stage when the packet would go to firewall. So it would perform NAT. When it performed NAT, the source IP would remain same. That is 135.1.1.120. That source IP would remain same. Source port number would remain same. Okay. That is 5621, let's say. But the destination IP, this time, the destination, which was 100.0.0.50, this is going to change over here. So destination would be, destination would be the private IP of TMZ server. Okay. So that is 172.16.1.10. So let's say this is a destination net happen over here. And what would be the destination port? It would remain same, 443. Now this server would also reply towards the client, because client requests for the service, and this is going to reply with the service. Okay, so now this server is going to reply. So on this is, let's say this is the third port packet where server is going to reply. So server is going to reply. So on that case, what would be the source IP? It would be IP of the server. 172.16.1.10. What would be the source port number? So port number would be 443, the port for the server. What would be the destination IP? Destination IP would be 135.1.1.120. So 135.1.1.120. This would be destination IP. What would be the destination port number? So it would be 5621. 5621. So this is reply from this server, DMG server reply. Then further it go here, okay, over here. On the next stage, packet would go. So in next stage, your firewall knows that this reply is for whom. So it knows that this reply is for the client who tried to access the website. Okay. So here it would put like the IP. It would be the public IP. Reply would be from public IP. I mean from netted IP 0.0.50. And then source port number. Source port number would remain same. That is 443. And destination IP would be your client IP, that is 135.1.1.120. And then finally you have destination port number, and destination port number would be 5621. So this is complete journey of your packet, you know, in the destination net. So you can see initially that over here you can see that when it is doing any kind of request from the outside to inside, basically this is inbound request, out to in. Okay, so it is known as an inbound request. So in inbound request, your destination IP is being changed. Okay, when that would happen, so in that your destination IP would change over here, and rest of the part would remain same. Okay, so this port number 443, this is not changed, this remains same, 443. So this port number 443 would remain same, but your destination IP is going to change, and that's why this kind of NAT is known as a destination NAT. Any question?
It's okay, sir. Clear.
Okay, good. Anyone else?
Hello.
Yeah.
Yeah. Actually, I got a question here. Actually, not related to this, but let's say we don't have a DMZ zone, right? And we have hosted this server into LAN, and that destination netting is happening. Every outside users are able to use this server, right? But I wanted to know that does the checkpoint support UNet, U-turn net?
Yeah, it does support.
Okay, so can you explain how it works? Because
UNet, I would tell you, okay, in some time, what is UNet basically. So in UNet, we can say if we don't have a private DNS and we have taken the public DNS, right?
Yes.
So in that case, we use UNet. So we can explain. I can explain you later. Okay.
Okay.
In some time. So for now, no question, right?
Yes. No question.
Okay. Okay. Now let's say what UNet. There is a UNet concept. Okay. That is also known as a U-turn net. So yes, in checkpoint you can achieve that. That is possible. Okay, let's let me clear this. Or I can use here in order to understand U-turn net. So let's understand U-turn net. What happened in U-turn net? Let's say this is my firewall. Okay, and there is some public DNS server available. And let's say this is my PC. This is the internal network, which is behind the switch. And there are some PC. in our network. Okay. Okay, I can use the pencil. Okay, so let's say these PC are connected. This is the firewall. Okay, and then we have DMZ zone. This is the internal, and let's say this is external. This is internet, and this is your DNS server, public DNS server, which is 8.8.8.8. And this is your firewall. Okay, now let's understand what is UNet. And Checkpoint by default support this kind of netting, UNet. So in UNet, you would have some server, and that server you would do the netting of those server on the public IP. So let's say, as I told, let's say this is labs.netminion.net, or let's take any other example. Let me write over here. So this is, let's say, labs.netminion.net. Then you have another server, and maybe over there you are running, study dot netmin.net, and over here maybe you are running online.netminion.net. Now let's say you have 3 servers, and by default these servers have a private IP. So let's say the first server you got the private IP, that is 172.16.1.10. On the second server you got some private IP, let's say 172.16.1.11. On third server you got some private IP, and let's say the third server IP you got 172.16.1.12. Respectively, you have netted these servers. So for example, let's say 172.16.1.10, you have netted to one of the public IP, and let's say that is 100.0.0.50. You have netted 172.16.1.11 to one of the public IP. Okay, and let's say that public IP is 100.0.0.51, and similarly you have netted your 172.16.1.12 to one of the public IP, and let's say this you have netted as a 100.0.0.52. So now you have 3 different server in DMZ, and those you have netted in a different public IP. Now, let's say when apart from that, after netting, what you have done, you have registered your domain. Okay, you have registered domain and you have mapped your domain as well. So not only you map the public IP, but you have registered the public IP against a domain. Okay, so each public IP is registered against a domain. So when I say register against a domain, that means what? Your labs.netminion.net would be registered against this domain. Your this one study.netminion.net would register against this domain, and this is the last one, your online.netminion.net would register against this domain. So that means when user is trying to access, labs.netminion.net, let's say this user is trying to access labs.netminion.net. What it would get? First of all, it would resolve the DNS. For this, it is going to resolve the DNS. For DNS resolution, it sent the query towards where? It sent the query to this DNS server. Okay. So this DNS server maybe resolve the IP that for this labs.netminion.net, your IP is 100.0.0.50. Now what it would do? Now this PC is going to generate the traffic for 100.0.0.50. Okay, so it would send the traffic towards the firewall.